Thanks, Ron. Yeah, it's been a pleasure working with Sean. We've done a few events together, and he really lays out the Bedrock story in a great way. And before I get into the rest of it, I can't emphasize enough how big a deal it is that the Claude 3 to 3.5 time frame was only a few months. And the other thing I want to point out there that I think is also really relevant for us in technology is that the price dropped significantly. So the change between Claude 3 and 3.5 is the model got better and the price went way down. And we're very much in a Moore's Law situation right now with AI. So as you look, listen here and see what we're doing with Bedrock, I think, sort of the sky's the limit where we can go from here. And it's been a really interesting trajectory with it. So we'll start with a little bit about Trellix. Hopefully you guys have heard of us before, but I find that many have not. If you haven't, we are the combination of McAfee Enterprise with FireEye. There's a quick little timeline there on exactly how the company came to be and some of the more seminal things that happened. I want to draw your attention there to the bottom here, which is a timeline of our use of machine learning and artificial intelligence. To really point out that a lot of the things I'm going to show you here are built on a long heritage of being able to be really good in not only machine learning, but data and data collection in the security use case. So way back in 2014, we invented a very common analytic now for impossible travel. It's essentially when you get a login from two places at the same time that would not be physically possible, as in that couldn't have been the same person actually logging in. And I'll detail exactly sort of what that evolution looks like and why that's so important, but it's been a very helpful analytic since then. And then a few years later, we added our guided investigations. We now show that as investigative tips. And that's been another really important building block for showing sort of the playbook to run whenever you get an alert. And then we added a lot of machine learning onto our endpoint products as well. So we got really good at that level of data. And then just last year, we launched what I'll show you here in a bit, which is our AI-driven auto investigations. And then after I show you what we're doing in Helix, which is our XDR architecture, Zach Kreider, my colleague, is going to go through exactly what we're doing to take that into our data security product line. So here's how we have been doing it before generative AI, and it's still very valuable and kind of shows what I would call more of the standard model, where you collect a lot of data, you put in one place, which is not easy. We got really, really good at being able to collect data from all over. Some of our other public work, we go in great detail on all the other integrations that we have and all the different supportive products where we can get data from because data is really the key to all of this. But we got really good at that over the years and really good at putting it in a data lake and indexing that data lake, which becomes critically important. And then, as I talked about with the impossible travel analytic, we also do a lot of matching, and that's not just simple matching. It's also kind of phased approaches where we have, something like correlation. And then we have a broad set of intel that we use to check to make sure that, if any known bad things, if they're occurring, then we'll flag them right away. All that goes into creating findings as an anomaly. We tell a human about it, and the human uses that super fast search on our data lake to figure out what to do next. So that's basically been, the status quo now for some time. You can do it well and you can do it poorly, but that's kind of been the model where you get the data in one place, see if there's anything interesting, you tell a human, the human does the investigation. Okay. Well, we have been able to improve on that. So here are those investigative tips that I was talking about. So this is what it looks like in the product, and I want to show you this because first of all, there's a bunch of questions in here, and this was a big deal, when it first came out. We were, really the only ones to kind of think about it this way and to say, hey, if you get this alert, you're going to want to investigate it. And we already know what the kinds of questions you're going to ask. So the same people that write the detection write these questions that go with the detection. And this has been really cool. But as you can see, that's a lot to read through. And if you get a lot of alerts, that's a lot of reading, and you're not usually going to have time. So what we realized was we could automate that part of it. And I think it's also interesting, just as a technologist, to note that we could always automate that part and run those questions and answers against the data lake, but it was still reading because the output still required a human to read through it. And this is the big moment. We realized that we could put in Bedrock at exactly this point. And so instead of taking every anomaly and handing it to a human and asking the human to investigate, now we have Bedrock intercept that. And so Bedrock now runs through all those questions and answers and decides, hey, is this something that a human needs to look at? So the human is still in the loop, but now we can filter out a lot of the noise. And so the human doesn't have to read through all that information. The human can be notified when there's something that actually needs to be looked at, which is usually a lot less than, the total amount. And so this has really been the big deal. And the reason that this works so well is that one of the things that generative AI is the best at is reading comprehension. So all of those questions and answers essentially tell a story about what has happened with the alert. And so we give the story to Bedrock and then ask Bedrock, hey, based on the output of this story, do you think that this is interesting enough for a human to look at? Yes or no? And we've gotten really good results with that because we're really using generative AI to do what it does best, which is that reading comprehension using that retrieval augmentation generation that Sean was just talking about. So we have all the data, and because we have the data, we can tell a very accurate, complete story that Bedrock can then read and decide what to do next and notify a human at that point. And then the human can provide that investigation. And so this is what it looks like. Our average customer has about 1 billion events per day that come into the data lake. We do that analytics rules and intel on top of that, and that produces something like 1,000 anomalies on average for our customers. That's how we had been doing it. Now, with the advent of Trellix Wise that uses Bedrock, we can use that system to curate that down to basically just the 10 things that matter. As in a given day, you probably only have enough time to run about 10 real investigations. So let's make sure that you're using your time wisely and focusing on the things that really matter versus just looking at things that were labeled critical. While those can be a good place to start, often what you find is that the really important stuff comes in as something that's lower informational at the time. And it takes that full story to figure out that there was something actually critical coming through. And so this is kind of what it looks like behind the scenes. So if you think of that screen that had all those questions and answers, essentially this is what the AI is doing. So it'll ask each one of these questions, and in parentheses there, I had sort of an estimate about how long it would take a human to figure this part out. It's not that a human can't do it, it's just that, humans have limited time and Bedrock does not. So we're able to go through each one of these and figure out after all of this, hey, does a human need to look at this? And in this case, this would have taken a human about 13 minutes. So it's just a good example of why you can't get through 1,000 alerts in a day. That takes some significant time. And so this is how you can get to that sort of magical moment where you have 100% alert coverage, where you're looking at every single alert, because sometimes these low alerts have real impact. So advanced threats are often very quiet. And in many incidents, I actually came originally from Mandiant. So did a lot of incident response. And in my previous job, I led an incident response team. So very familiar with what incident response looks like and all the things you need to do there. And I can tell you that frequently, if a bad guy gets in, there are probably pieces that they created a trail the entire way in, but they may not have been noisy enough to notice at the time. And that's what's so important about what AI can do here is that by looking at every single alert, regardless of whether it's big or small, it can provide that service for you. It can figure out based on all the other things going on, is this actually something important? And so because it can investigate all these alerts in under 3 minutes, you don't have to wait around to figure out if something is actually going on right now. On top of that, we're able to pre-build a lot of these dynamic playbooks to capture the full story. And because the AI, as I'll show you here in a second, describes its decision-making process, you have a complete audit trail. So not only can you claim that, yes, we've analyzed every single alert that's come through the system, you have all of the work to show for it. So for any question, you can look at exactly how the decision was made, which not only helps with auditors, but it's also important for just building trust in the system overall for you as the user of it. And then lastly, as I mentioned, AI is only as good as the data that you give it. So making sure that it's got that full story from every available bit of data from our entire platform and all of our integrations is really what makes this work. So let me give you some specific examples here because these slides are great, but let's see the proof. And this is, I think, one of the most seminal pieces that I've seen. It's very relevant right now. You may have seen the news that there was some more fallout from a hack from a company called Snowflake that does a lot of big data. And AT&T was the most recent large headline. Honestly, it was an actual headline. Hey, AT&T lost a lot of data. How did this happen? Well, part of the story is that it wasn't so much that the software was vulnerable, is that a stolen credential was used against a place where they only required a single factor, as in if you just had the username and password, you could download the data. It was really that simple. This is copied and pasted from the output that from our product from Bedrock that shows, and this was, I think, 2.5 months ago, so prior to the issues with Snowflake. But look how helpful and predictive this was. So it's pointing out, based on all this information, it noticed that this comes from our demo environment, and it noticed that this was a demo user, and it even calls out here directly. Demo users can be more prone to compromise if the credentials are shared. And this is why I think this is such a powerful moment, because it shows you just what it's like to have an AI that's evaluating, these stories of data, because it understands the concept of a demo and understands the concept of a demo user. And in a security context, it even knows that those credentials are likely to be shared. So this is an especially dangerous moment. And then, this is exactly what happened with the Snowflake issue. So just as a example from the headlines here, this is the power that you can wield against the data that comes in is having generative AI that's essentially read everything that's on the internet and fully understands MITRE attack frameworks. It fully understands OWASP top tens and understands threat models. And it has that general knowledge. You combine that with the specifics, the tactical information that we could provide it, and suddenly you have an incredibly powerful tool. So here's those articles that just came out, I think, June 5th, and this other one on the left here was actually just a couple days ago. But right there, Snowflake said their own systems weren't breached outside of one employee's demo account. There it is. And on the other side, how a third-party attacker was able to use stolen credentials to access what it was classified as demo account data. And there's plenty more of those out there, but it's that simple concept that this is not just machine learning. This thing actually understands the concepts of security, and so you don't have to fine-tune train it on a lot of different things as long as you have the right data to give it. So how does this apply to an Amazon environment? Well, this is an alert that we've got. It's a very low level, and it's simple. It says anytime instances are manually created or started, create an alert. Now, this happens on a regular basis in many environments. So this is an informational level alert. This is just a note that something happened. We put this in there because in a lot of environments, you use CloudFormation. You don't use something, manual. That's a very strange thing to happen, and you can, in fact, dictate that should not be happening anywhere as a matter of policy. So in some orgs, this is an important alert for them, but many it's not. The critical thing here is this is a way to get the AI's attention and say, hey, we need you to take a look at what's going on here. And in this case, well, the login for starting those instances manually came from Tor. The AI understands the concept of Tor, and it even understands that is a very strange thing to happen in an enterprise environment. And then it noticed that there are other rules because we had those playbooks for it to run, those investigative tips, and it saw that there were brute force attempts that turned into successful logins from that password spray attack, and went so far as to create suspicious inbox rules like forwarding, which is typically what an attacker will do. So I was able to put all that information together along with the fact that this is very strange to happen in an enterprise environment, and say, yeah, just because these were manually started and created, this is actually a big deal. And critically, someone needs to look at this. And that's the key here, is that because you're reading this, you have been notified. If the rest of that information wasn't there, then it would note that there wasn't enough to go on and file that away in our audit log so you can see the decision that it made, but you wouldn't be bothered by that particular low-level alert. So that's just an example of how this works. But this is the upshot. You have something that will dig through that bottom 90% of things that were never going to get looked at, like that manual instance creation, and now it will go and do that, bubble that up to the surface so you actually have something to look at. And just to kind of understand what this means in human terms, this is a way to scale out your staff. So if you said, well, we want to hire enough people to actually look through every single alert to make sure nothing's getting through, that never happens because you'd have to hire a lot of people. And for our average customer, at 1,100 alerts per day with 65 events for each alert and 5 seconds to read an event, you're looking at 12 8-hour shifts worth of people. So you'd have to hire 12 people in order to just handle the alert volume for our average customer. And that's why no one does that. And that's why things slip through the cracks. So now we have generative AI to run and answer the question. One other thing I want to point out here is that we can actually tune this. we can provide additional information and guidance to the AI so that it makes better decisions for your environment. So let's say that you have an environment where it's actually normal for people to log in from a lot of different geographic locations. That's okay. You might be getting some anomaly detection from our system saying, "Oh, hey, that looks like an anomalous amount of logins from this other geo." But you say, "No, this is what to expect in our environment. We have many logins that come from all these different places, and they use this system." You don't have to turn off the other analytics. That instructs the AI and just describes what your environment looks like. It will use that in conjunction with the tactical information that it's given and say, well, I have this login anomaly, but you said that it's normal for your environment, so I'm not going to escalate this. So instead of turning things off, you just do a better job of describing what your normal environment looks like, and it will take that into account. And this is a really powerful concept that we've never had the ability to do before in the security industry, is to be able to just naturally describe what your environment looks like and have it take that into account. And so what we have here is, before we were basically doing data mining, and now we turn that into alert mining, because suddenly we have an efficient way to look at every single alert. So instead of turning these alerts off, you want to get them all into one place and have them fully evaluated. But you don't want to do that with humans. That doesn't scale. You want to do that with the AI. And so now not only do you cover all of the alerts, but now your staff can spend time at the human level and operate on things for the organization versus, clicking through, a lot of small, boring things that it takes to previously operate in an environment like that. That was never the idea. No one wanted to be clicking around a lot. People wanted to just find the bad stuff. And so now we can make sure that humans are focusing on that.
I'll also just add one thing, Martin. In my personal experience, I've seen a lot of negative activity come up in the wee hours of the morning when different time zones are more active. So having AI active at that time when maybe your team's asleep is really helpful.
That's a great point. AI doesn't get bored, it never sleeps, and it doesn't get sick. So if you can give it the right information, it'll do a really good job telling you what you need to look at. With that, I'm going to turn it over to my colleague, Zach, and he's going to run through how we've been able to use this on our data security side.
Yeah, thanks, Martin. So we'll go through of how we're leveraging Trellix Wise to help customers as they go through their data security journey. And so as we talk to customers, they usually, a lot of customers and organizations are really concerned about data sprawl, right? Leveraging multiple different cloud environments, really the explosion of SaaS applications, generative AI applications that are now touching data, understanding how that data is being used with those models. And then obviously at the end of the day, the end users of the data they're touching. And so organizations really want to understand, where does that data reside? Who and what has access to that data? What's the overall sensitivity of that data? Is it sensitive or secret for the organization? Is it something public that we're okay allowing a SaaS application or a Gen AI application have access to? Or, should it only be restricted to a certain department, like legal should only have access to this data? This is usually where customers struggle. And so one of the things that we're doing in leveraging Trellix Wise, as we look at data security, going beyond just the traditional data security or DLP, how that's usually set up in organizations, is how can that help customers really automate and be a lot more efficient to really understand where the data resides in their environment, give them proper visibility across the organization of the data locations, but also classifying that data. So being able to reach out and say, the data that's in this S3 bucket, we went through and analyzed it. It's all sensitive data that should only be restricted to our organization, or data that's sitting on this database or this particular server. It's intellectual property, right? So we want to restrict what applications can actually have access to that or what users can touch it. But then really just going beyond that too, of you can set out these policies, classify the data, but at the end of the day, the users are really the biggest risk to the organization. And so really understanding the user risk. So being able to profile and build out a risk score for a particular user. Maybe they're new to the organization and all of a sudden we see a lot of activity where they're connecting to a server that has this sensitive information on it. That'd be, alarm bells going off. Or maybe it's a low performing employee in the environment and we see them start downloading a lot of data to their personal machines or their laptops. Right, that potentially they could be using that to harm the organization. So being able to build out the risk scoring from users from that standpoint to really understand if when they're interacting with data, is there other intents that may be going on that are beyond just a system standpoint, but also being able to do system risk scoring to understand, hey, we have this database server that is public facing, and stored on it is a lot of PII data for our customers, right? We want to make sure that data is encrypted. We have the right controls in place, and providing the risk ratings of as events occur. We're able to correlate all this to escalate the right events at the right time for people to look into it. But then also at the end of the day, when you talk about data security, one of the biggest driving factors around data security or data loss prevention for organizations are really regulatory requirements. So regulatory requirements may be based on the industry that you're in or the geolocation that your organization's in. These regulations are being pushed out, weekly or monthly. And, teams really struggle trying to keep up of one, just understanding what the regulation means to them, but then also building the right policies, the right detection capabilities in their environment for data security to deploy out to comply with that regulation. So customers spend a lot of cycles going through that. And one of the things that we're leveraging Trellix Wise to do is really understand the regulatory requirements that are being pushed out and actually be able to build out your data security policies to align with those regulatory requirements, and then just presenting those policies to the operations team where then they can review it and go, yes, we want to turn on this rule. Maybe we just want to monitor this rule because it could impact business. But being able to react quicker to those requirements as they come out and having AI partner with you to actually build out your data security program. But also too, once you roll out data security, this is usually when the tidal wave comes of all the events are being generated now. There's these new rules that have been pushed out. Maybe someone left a rule in low severity mode that's just kind of monitoring all activity. Usually when this occurs and these events start going up to your security operations team, 9 times out of 10, they're going to go back and tell you either go tune this rule or turn it off from sending us this data. But then the result is they could actually be missing out on critical events. They're just getting overwhelmed with the data that's coming in. And from your operations team that managing the solutions of the events that come in as well from users, they're asking the same questions of what particular event should I focus on? When does the event occur? Where did it occur? Am I even confident that this is, a legit event I should look into, or is it a false positive I should just ignore? How do I summarize this activity and give it back to an end user to explain, what they did? And then if it is a legit event, like what steps should I take to actually investigate this further? These are very common questions that we see organizations really try to get their arms around and understand as they tackle data security. But this is where we're leveraging Trellix Wise to assist them in this overall process to take a lot of this burden off their analysts and do a lot of heavy lifting. So when they get to the console, they already see the events, they've already asked all these questions and provide them that information. So they make a determination, oh, this is good, we blocked it, we can move on, or I need to reach out to the user. But I just want to kind of walk through kind of what this would look like. So in our ePolicy Orchestrator console of how you can manage our data loss prevention endpoint technology for users, this is a very common scenario where someone may build out a rule that's just monitoring for HIPAA and PI data being uploaded to a website. They may set the rule severity of a warning, which is low severity, and apply it out to the endpoints. Now, once it's actually applied to the endpoints, your users are going to start doing their day-to-day activities. They're uploading data to websites or dumping something into ChatGPT as an example, uploading a file. These rules are going to start triggering the environment. So in this case, we push out that rule to an endpoint. It's now triggered, and now it's creating an event that's being sent back to the ePolicy Orchestrator console. Now, traditionally, when these events occurred, they just sent the ePolicy Orchestrator console that an analyst has to go through each event and determine this is a legit event I need to focus on, or I can ignore this event. But in this case where it was low severity, majority of the time, they're just going to ignore those low severity events and just mark as ignore or just move it out of the queue. But the reality is something really critical could happen and they're actually missing something that they need to investigate. But because there's so many events, they're just going to ignore that. So what we've done is leveraging Trellix Wise, leveraging AWS Bedrock in the back end, we're now able to send that data and the contextual information that we have from the endpoint and user information that we have in the ePolicy Orchestrator console to actually do a full analysis of the event on behalf of the analyst. So we're able to determine what's the overall severity of the events, should it actually be raised to a higher severity that someone should go look into, and provide all the analyst notes directly back into a case that an analyst can pick up and look into. So this is a great example. The event occurred, we had that low severity event, but because Trellix Wise was able to take all the contextual information about the rule itself, how the rule is configured, end user information that EPO was able to collect, and then information about the endpoint, what data resides there, it was able to determine this PI data that was uploaded to the website was actually occurred from an IT help desk analyst that is a tier 1 analyst. They shouldn't even be having access to PI data. And because of that, we're able to determine this is actually a high severity event. Someone should go investigate as to why this user was touching this data and why they were trying to upload it directly to the website. The really cool thing about this too is we're able to provide a quick summary of what occurred in the events and provide non-technical steps in summary that an analyst can actually provide back to the end user to explain, that we blocked this activity on your machine, but here's why it was blocked. Here's how to avoid this in the future, or things to keep in mind as you're touching data. But even going further too, of providing information for the analyst to dive deeper into the event of what additional investigative actions do they take, what areas should they also research into on the end user's device, or what other activity that the user occurred in the environment. And then we're also able to go through and say, hey, this role that was built, here's some recommendations of how you can tune this role to be much more efficient, because right now it's pretty broad. And then also too, you had the severity set at very low, but let's put it at a medium or high severity in the future as you roll it out. And here's our overall confidence score too of the raising of this particular incident. So we'll just kind of walk through what that actually looks like in real time.
Hey, Zach,
So,
just one quick thing. We've got about 2 minutes left, so I just want to make sure you're aware of that. And I always want to keep this interactive. Victor with FedPoint, the large processor of benefits for so many federal employees, had a question about how does DLP, your solution, work in S3 instances. Victor, I unmuted you. Can you have any other information on that, or did you just leave? And I think I might have just missed him. So,
No,
okay.
that was good for me. We're looking to offset the Macy, and we just wanted to see if it does more than what Macy does with EC2 and RDS databases for data discovery and data leakage for data at rest.
no, good question. So we can actually monitor of like users, how they're interacting with the data, and also do discovery scans. So all these S3 buckets out there, what data resides in it, how's that data actually classified, and how does it align to your policies? So we have the ability to do auto discovery scans in an environment, whether from endpoints, databases, SharePoint sites, or S3 buckets. We're able to reach out to those, do a scan, and just help you understand what data is actually there and what's the overall sensitivity of that particular data, so you understand of, hey, we have this S3 bucket, it may have a lot of sensitive data on it, and we just need to make sure it's locked down or monitor what users are actually accessing that, or applications are actually accessing that particular location. So we can do endpoint-based and network-based. Yeah, and so if you have any questions, definitely reach out to Ron, and we're happy to set up additional calls with y'all to actually walk through this. But I'll hand it over to you, Ron.